We've already learned about arrays and how useful they can be in storing large quantities of data that can be accessed at any time. But another thing that makes arrays so great is that the values can be searched to find certain values that are required by the user. An example can be if we're looking for a certain student's marks, we will first search for the student's roll number and then we will return the marks that are corresponding to that student's roll number. So with that in mind, let's learn how we can search through arrays to find certain values. The first searching technique that we're going to be looking over is probably the easiest one. It's called linear search. Now, let's say, for example, that you have an array in front of you and it has a set of numbers in it. How would you try finding a certain number in it? You would try skimming through the array until you find the first occurrence of the number that you're looking for. So this is exactly how the linear search technique works. It's a sequential search technique, and in this search technique, all we do is we go through each and every element of the array and search for the certain value that we're looking for and return it. Now, algorithm for the linear search is pretty simple. All we have to do is create a for loop and initialize a variable to be 0, which will be the beginning point of the array, and the for loop will run as long as the variable is less than the length of the array. And then we have to compare each element of the array with the value that we're trying to search for. Let me show you this in code. So let's say, for example, that we're searching the array for the number 5. So we first create a class, we create an array int arr, and then we define a set of values. Then we open the function void main, and we create a for loop in which I is equal to 0, I is less than arr.length, and note that it has to be less than, because if it's less than equal to arr.length, then it will lead to an exception because I will go beyond the index range of arr, the array arr, and we increment a I every time the loop finishes running. Now, if arri is equal to 5, which means that the value in this certain index position is equal to the value that we're looking for, then we can print to the user that we have found the number and we can exit out of the program. But in the situation that the number that we were looking for, let's say we were looking for 11, uh, since this number doesn't exist in the array, it will go to the second system.println statement after the for loop, and it will print that the number is not in the array. Now, what are the advantages and disadvantages of the linear search technique? Well, advantages are it's simple and it's a very simple technique. Let's be honest, it's quite simple. It's just a simple for loop, and we check each and every value in the for loop. Another advantage is that the array doesn't need to be sorted, and you'll get why this is such an advantage soon enough. But the disadvantage is that it's not ideal for big arrays. Let's say, for example, that we had an array of 1,000 or 10,000 elements, and we were looking for a certain number which existed at the back of the array. Now, by the time we even reach that number, it will take like 6 to 7 seconds, which is something that we wouldn't really want. And it could possibly even take longer than that. And so it is a big disadvantage because it takes too much time when it comes to big arrays. So always use the linear search technique when it comes to smaller arrays. All right, so the binary search technique. In this search technique, it is important that the array is sorted, which is different from the linear search technique in which the array didn't need to be sorted. Now, a note to keep in mind in the binary search technique is that it uses the divide and conquer technique. If you know what it is, it'll be easier for you to understand. But even if you don't, it's alright. You'll understand it either way, and you'll even understand what divide and conquer technique refers to. Now, in this technique, we keep checking if the middle value between the two variables is equal to the desired value. And you'll understand what this means in just a second. So I'm going to be trying to explain to you the algorithm of the binary search technique. I'm going to be explaining the algorithm and I'll be showing you an example followed by the code to help you understand it better. Now, First, we have to initialize two variables outside of the while loop. Now, it's always preferred to use a while loop for the binary search technique, but even if you want to, you can use a for loop. Now, one of the variables value will be 0, while the other one will be array.length minus 1. And the names I prefer using for this are for these variables are first and last, but you can keep it as whatever you would like. Now, inside of the while loop, we have to initialize another variable. The name I prefer using is mid, and its value will be first plus last divided by 2. Now, it's important to keep this variable inside of the while loop because first plus last, the value of first and last will keep changing as we keep searching the array. So that's why it's important to initialize it inside of the while loop and not outside of it. Now, keep in mind that mid, first, and last, all these three variables refer to index positions and they aren't actual values that we will be comparing with the elements. What I mean to say is that it will be array mid in square brackets, which will be compared to the desired value and not mid being compared to the desired value. And you'll see what I mean when I show you the code. Now, we have to keep a few if conditions inside of the while loop. So the first if statement can be if array mid is equal to the desired value, then you can perform whatever code you want or you can just return that value. Now and then if it's not equal to array mid, then we should check if array mid is greater than the desired value. Now by doing this, we're checking if the middle value between first and last is greater than the desired value. Now, first and last are going to be variables that will be telling us the beginning index position and the last index position between which the desired value is. And I'll explain this further when I show you the example. But for now, just remember that if array mid is greater than desired value, this means that the middle value between first and last is greater than the value that we want. So we need to reduce the value of the last variable so that the value of mid also reduces, so that in hopes that it becomes equal to the desired value. And if array mid is not greater than desired value, then it'll go to the else statement, which means that array mid is less than the desired value. And so we need to increase its value. We need to increase the mid value by increasing the value of first and by increasing the value first. Yeah, that's pretty much it. Now this is the example and I'll explain it to you step by step. So we have an array 1, 5, 7, 8, 13, 19, 20, 23, 29. Now the value of the variable first will be 0 and the value of variable last will be 8. Now when the executor enters inside of the while loop, the value of mid will be 4, which is first plus last divided by 2. 0 plus 8 divided by 2 equals to 4. And it will check, is array mid equal to 23? No, it's not. Is array mid greater than 23? No, it's not. Now it's reached the else statement, which means that array mid is less than 23. And so to increase the value of mid, we'll have to increase the value of first. And so in this case, the variable big is is the same thing that you would keep as first, and end is the same as you would keep as last. So big becomes equal to mid plus 1, which means that we're increasing the value of big so that we can increase the value of mid in hopes that it becomes equal to the value of the it becomes equal to the desired value. Now mid is equal to big plus n, 13 plus 2, which equals to 6. Now we check. Now array mid is equal to 20 now because mid is 6. Is 20 less than 23? It is. So again, we'll have to increase the value of the beginning variable, or first, as I prefer using it as, we'll have to increase it. Now by increasing it again, the value of mid increases as well. And now we're again hoping that by increasing the value of mid, it will become equal to the desired value. Now, by increasing the value of big to mid plus 1, it was 6 before, so 6 plus 1 becomes equal to 7. Um, Now, when the while loop reaches to mid is equal to big plus n divided by 2, it becomes equal to 15 by 2, which is 7. Now, mid's value is 7. Now, array array 7 in square brackets is equal to 23. Is 23 equal to 23? It is. And then we can return the location 7, or we can return the value 23, or we can tell the user that this value was indeed present. Now, let me show you the code. Now, we create a class binary search, public static void main, int role, which is going to be, now in this example, what we're going to be doing is we're going to be trying to search through a list of roll numbers, or an array of roll numbers, to try to find a certain roll number. And we're trying to find 34 in this example. And we keep a Boolean variable, which is check, which is equal to false. Now int first last mid, first is equal to 0, last is equal to roll.length minus 1. Okay, just as I told you in the algorithm. Now, as long as first is less than equal to last, now this first is less than equal to last is important. It has to be less than equal to and not less than, because if it's not, if it's not less than equal to, then we might miss an iteration. And in certain cases, it does result in errors. So remember to always keep it as less than equal to. Now remember to give the value of mid inside of the while loop, because the value of last and first keep changing. If roll mid is equal to find, then we set the value of check equal to true. We print that the roll number is found, and we break out of the while loop. Else if the value that we're looking for, the desired value, is less than the middle value, then we have to reduce the value of last so that the value of mid also reduces, in hopes that the reduced value of mid becomes equal to the desired value. And else, as you know, we'll have to the desired value will be greater than the middle value, and so we'll have to try to increase the middle value by increasing first to try to get that value. Now, if check is equal to false, it means that the roll number was not found. And since in this array it is found, it will print roll number found, and it won't and check will be true, so roll number not found in the list won't print. Now, with that in mind, you all know how exactly the binary search technique works. So what exactly are the advantages and disadvantages of this? Now, the advantage is that it's ideal for bigger arrays. Let's be honest. For this array, all we needed were 3 iterations. But if we use the linear search technique, it would take 1, 2, 3, 4, 5, 6, 7, 8. It would take 8 iterations of the while loop to try to get to that. So you can see that you're already saving time. But the disadvantage is that it's a little more complex than linear search, but for the time that it saves, I think it is worth it. And the array also needs to be sorted before, and this is where your sorting techniques come into play. So by sorting the array before you use it, before you try searching a value inside of it, you can use binary search. Now, another thing to note is that this code that I've shown you is for if the array is arranged in ascending order. If it's arranged in descending order, then you'll just have to reverse the else if and else statements. That's all. And with that, you know exactly how to search through an array using binary and linear search techniques.